Hi guys, Reinhardt here, talking about parallel and perpendicular lines, as well as the cool concept of a transversal and what that means. But before we can get there, we need to review some angle properties. And you need to know the word sum. That means the answer to an addition problem. So angles whose measures have a sum or add up to 90 degrees, they can be two or more of them, are called what? Pause the video if you need to. Otherwise, you yelled out complementary. Vertical angles, those are the ones that are straight across from each other like this or like that. Vertical angles have equal measures. They're equivalent. That means they are what? Give you a hint. This is a symbol for that. You say congruent. All right, angles whose measure have a sum of 180 degrees. That means they add up to 180 degrees. Give me two or more angles. 180 degrees is a straight line, so any angles that add up to 180, like A plus B plus C, are called supplementary. That's a key one today that you'll need to know. A part of a line between 2 points is called a what? A line segment. So between any 2 points, this thing here is called a line segment, and if this was called ZA, just for extremes, how would you name that line segment? Of course, you said line segments need to be in alphabetical order. They don't have the dots when you name them, and it's A, Z, because A comes in the alphabet before Z. Everything's alphabetically when you're naming lines are points, except for the ray. The ray is non-alphabetical. Go ahead and pause this video and title Notes 7-2. And the key concepts today are parallel lines. They're lines in a plane that never ever meet. Examples would be the windows in the building, and also like a train track. They're infinite, they never ever meet. The slope is also the same. Perpendicular lines is like an intersection at a four-way stop. Intersections meet at 90 degrees. That means all the angles are 90 degrees. Symbol for parallel, that's this guy. And perpendicular looks like this, an upside down capital T. So how I remember these guys meet at 90 degrees. So that's how you would write parallel versus perpendicular. So this is a real world example. Train tracks are always parallel because they can never meet, and the railroad ties that intersect them are also called transversals. A transversal is just a type of a line that cuts through another pair of lines, so two or more lines. So any line that cuts through two or more lines is called a transversal. That's that guy. If you wanted to draw two lines and then cut it, the one that cuts is called the transversal. Cool thing about a transversal that cuts parallel lines, it has some really unusual properties, rules that we can use to figure out any angle. And these rules are called alternate interiors. So the angles on the insides, these blue guys here, they are on opposites, so they make kind of the S. Those two will be congruent, and the salmon ones will also be congruent. They're opposite inside angles, or alternate interior. There's also something called alternate exterior, and as you know, the exterior is the outside. So you look on the outside of the lines, and the ones that are opposite on the outside are called alternate exterior angles. They are always congruent. Corresponding are the same colors here. You see the green guy and the green. They're both the acute angles on the same side of the transversal, and the salmon ones are the acute on the same side of the transversal. The purplish color ones here are the obtuse angle, and the blue are also obtuse. So all the obtuse angles will end up being congruent because these guys are vertical angles, and vertical angles are congruent, and the acute angles will also be congruent. So this is basically what I just said. Take a minute and pause the video and read it. So these properties make it really cool to understand what a transversal is, and a transversal, again, is any line that cuts two others. But when they're parallel, when a transversal cuts the parallel, that's when you get all these properties. So if you look at these lines here, two lines cut by a transversal. So let's call this line A, and this one line B, and let's call a transversal C. The transversal is line C. A and B are parallel, therefore you can make a congruent statement. So the congruent statement is the measure of angle 1 is equal to 3, 5, and 7. So all of these angles are congruent to each other. And all the red ones are also congruent to each other. So the purplish ones are obtuse, so all the obtuse angles are equivalent. 1 and 3 are vertical angles, 5 and 7 are vertical angles, 5 and 3 are alternate interior, 7 and 1 are alternate exterior, and they're all congruent. And then the red guys are also all congruent. 2 and 4 are vertical angles, 6 and 8 are vertical angles, and then 4 and 6 are alternate interior, and 2 and 8 are alternate exterior angles. They're all congruent. And these things here are called congruent statements. So when I'm asking you to write a congruent statement, this is what it looks like. The measure of angle 1, 3, 5, and 7 are all congruent. This symbol here is the congruent symbol. It needs to go in between your angles that are congruent. M stands for measure, and angle 1, angle 3, angle 5, angle 7, and these can be in any order as long as they're equivalent to each other, congruent to each other. It doesn't matter if you write measure of angle 7 is congruent to measure of angle 3, is congruent to angle 5 and 1, as long as you have all of them. And all of them are always going to be obtuse or all acute. So when you measure angles with the protractor, you're never exact because you're human and our protractor isn't always perfect. But if you know that A and B are parallel and C is a transversal, then you can determine any angle by knowing just one. So I'll give you an example here. Let's say the measure of angle 1 is 150 degrees. If that's 150, then you can figure out all other angles. So if measure of angle 1, that's this guy here, is 150 degrees, right away you can see that angle 1 is obtuse. So you look for any other obtuse angle. I'm going to go with a vertical angle because vertical angles are congruent. So I would know 3 is also 150 degrees. Look for another obtuse, or you can say, oh, this is an interior angle. Its opposite interior is congruent. So that means 5 is 150 degrees. And then right across from that is 7. They're vertical angles, and vertical angles are congruent. And then 7 and 1 are alternate exterior angles, so they're also congruent. Now for the acute angles, you can pick any acute angle that you wanted. Let's say I wanted to start with 4. If I wanted to figure out this measure, check out 4 and 1. If you were to unfold 4 into 1, it would make a straight line all the way down. That means they're supplementary. So to figure out 4, you would take 180 degrees, because 180 degrees are in a straight line, minus 150, and you get the difference of 30 degrees. So angle 4 is 30 degrees. Its vertical angle is 2, so that one's 30 degrees. Well, let's check. Does 30 plus 150 make a straight angle of 180? Yep, so you did your math right, and you can continue. If this is an interior angle, alternate interiors are congruent, so this one's 30 degrees as well. Its vertical angle is also 30 degrees. So it ends up being all acute and all obtuse angles are congruent. Take a look at the bottom of the screen. I just wrote a little congruent statement for the acute angles. Measure of angle 2 is congruent to 4, congruent to 6, congruent to 8, and they're all 130. If I wanted to write in a congruent statement for the obtuse angles, or the purple ones, I could do the same. I just pick one obtuse. It doesn't have to be in any order. So let's say 1, equal sign with a squiggle on top. That means a congruent. To measure of angle 3 is congruent. To measure of angle 5 is congruent. To measure of angle 7. Whoops. In that 7 looks like that, and they are all equal to 150 degrees. Now when you check, these two numbers should be supplementary, means they should add up to 180. So you just want to double check that the acute and the obtuse add up to 180 degrees before you move on. Okay, try this one. If you're given measure of angle 4 is 36 degrees, pause the video and see if you can figure out all the other missing angles. Well, from here, after the pause, you see that the vertical angles are congruent, so 4 and 1 are the same. And that means 5 and 8 are the same because they're all the acute angles. So all of them will be 36 degrees. So pause the video and see if you can figure out all the obtuse. So what I did to figure out what the obtuse angles were, I took 180 because 180 again, it makes a straight line here. And I know that 1 and 2 would add up to 180, or 3 and 4, or 2 and 4, or 6 and 8. So I just took one of them and subtracted 36 degrees is what my known is. I got 144. So that means all my obtuse angles, 2, 3, 6, and 7, are going to equal 144. And this is called a congruence statement. In this example, line L and line M are called parallel lines, and they're cut by a transversal. And usually the transversal will have a name on it, so you can just make up any letter. Let's say it's transversal T. If in transversal T, this angle is given to you, it's 124 degrees. That means it's an obtuse. That means all the obtuse angles are going to be 124 degrees. So see if you could figure out what 3 would be. If you said 124 because they're vertical angles, and 3 is also obtuse, and then 4 because it's obtuse, it's more than 90 degrees, and it's its alternate interior angle, 124 degrees, and then you look at its vertical angle of 7, it's 124 degrees. That means you should have all the obtuse angles done, and they're all 124. So to figure out the acute angles, you just need to take your known angle of 124 and subtract it from 180, because these two will add up to 180, or these two will add up to 180, and you get 56 degrees. So all the vertical angles, or all the acute angles, are going to equal 56 degrees. So you should be able to find any angle as long as you're given one, and that you know that L and M are parallel and cut by a transversal. Try this one on your own. So in this one, all the obtuse angles, you should have got 144 degrees, and then all the acute are 36 degrees. So 1 and 4 are vertical angles, they're congruent. 5 and 8 are vertical angles, they're congruent. 4 and 5 are alternate interiors, they're congruent. 3 and 6 are alternate interiors, so they're congruent. And then you have your alternate exterior and your alternate interior, which are congruent. So if you're given A and B are parallel, you can write a congruent statement that 1 is the same as 3 is the same as 5 is the same as 7, and 8 and 6 and 4 and 2 are all congruent. So if you're given any one angle, you should be able to figure it all. All the angles that would be congruent to angle 3, you'd say angle 1, 5, and 7. And you'd write it like this. Measure of angle 1 is congruent to measure of angle 3, is congruent to measure of angle 5, is congruent to measure of angle 7. Supplementary to angle 6. So all the ones that are supplementary to angle 6 means they would add up to 180. So this double lined one plus any single one would add up to 180. So you could say angle 5, angle 7, angle 1, or angle 3, or all of them. They are all supplementary because they all would add up to 180. If 1 would be 105, what would 3 be? Well, since they're vertical, the measure of angle 3 would also be 105 degrees. If it said that measure of angle 5, now this is obviously just a hearsay, because if 1 was 105, then 5 would be 105. But if it gave you a different number, like if 5 was 120, what would 2 be? Notice that they're on the opposite side, so 1 would be 120. That means you'd have to take 180, subtract 120 to get 50 degrees for measure of angle 2. Measure of angle 2 would be 50 degrees. That's it. I want to say thanks for watching, and let me know if you need any help or have any other questions. Thanks.